Microsoft has suddenly shut down one of its most advanced quantum labs in Sydney, Australia. This isn't just another corporate restructuring. It's a seismic shift in the global quantum computing race that almost no one is talking about. The most shocking part, what Microsoft isn't saying publicly, might be more important than their carefully crafted press releases. The Sydney team wasn't working on just any quantum technology. They had created breakthrough systems to control millions of qubits. Now that revolutionary knowledge is either being centralized in the US or possibly buried. Imagine spending years solving one of the biggest engineering problems in quantum computing, developing a chip that could function at near absolute zero temperatures, only to be told, we're moving everything to the US. What would you do? Stay loyal to the company that's cutting you loose, or risk everything to build something entirely new? The hidden motive. Microsoft claims this closure is just part of ongoing consolidation as they accelerate from research to productization. But the timing raises serious questions about what's really happening behind closed doors. This shutdown suspiciously coincides with escalating tensions in the cosmic quantum frontier, where governments are racing to harness quantum power for decoding the universe's deepest secrets. Microsoft's project was one of only a handful pushing the boundaries of simulating black hole interiors and quantum entanglement across vast cosmic scales. Suddenly, they need all hands on deck in America. Looking deeper, the closure aligns perfectly with the US government tightening control over quantum research under export control laws. Quantum computing is now classified as a critical technology under ITAR regulations. Having breakthrough research happening overseas became a liability overnight, especially when it touches on simulations that could reveal hidden dimensions or the fabric of space-time itself. Two senior Microsoft executives flew to Australia with an ultimatum for the 15-person team. Relocate to Microsoft headquarters in Redmond, Washington, or lose your jobs. The compensation offers were astronomical. Salaries large enough that after a few years, one could buy a house in Sydney without a mortgage. But here's the twist that changes everything. This lab wasn't even building qubits, like Microsoft's other quantum facilities. They were solving something potentially more valuable: how to control millions of qubits without miles of wiring or impossible cooling requirements. Their breakthrough cryogenic chip could revolutionize the entire field by eliminating the biggest barrier to practical quantum computers, unlocking simulations of wormholes, multiverses, and even the quantum signatures of potential alien civilizations lurking in the cosmic void. Groundbreaking tech that got locked away. What exactly was this Sydney team developing that made Microsoft so desperate to keep them? A revolutionary cryogenic qubit controller chip that changes everything about quantum computing. This chip does something no other quantum technology can do. It operates directly inside the dilution refrigerator, right next to the qubits at near absolute zero temperatures. If you know anything about quantum computing, you understand this solves the biggest roadblock to practical quantum machines. No more wiring problem with thousands of cables running in and out of the freezer. No more heat contamination destroying quantum states. Just pure, direct control of potentially millions of qubits from inside the quantum environment itself. Industry insiders suggest this technology was possibly years ahead of what IBM, Google, or any other quantum player has achieved. The 2021 breakthrough they published was just the tip of the iceberg. Sources close to the team have revealed there were unpublished breakthroughs of commercial significance that Microsoft never made public. Team members privately admitted some of their work was 2 years away from commercial-grade implementation that could revolutionize quantum scalability. Here's the kicker. Microsoft still owns all the intellectual property from the lab's 7 years of innovation. They have the patents and the designs, but they lost something potentially more valuable: the people who created it and knew how to push it further. Let me put it this way. If your team figures out how to shrink the brain of a quantum computer and put it right next to its neurons, and then walks out with that knowledge, that's not just innovation. Walking out the door, it's firepower in the quantum arms race, capable of modeling the birth of stars, the collapse of black holes, or even detecting faint quantum echoes from extraterrestrial intelligences across the galaxy. But the story doesn't end there, because the people Microsoft tried to relocate. They had other plans that would send shockwaves through the quantum computing world, rippling into the mysteries of deep space and the hunt for life beyond Earth, rebellion, and the birth of Emergence Quantum. Microsoft's ultimatum to the Sydney team was clear: move to Redmond or lose your jobs. The compensation package was astronomical, salaries so high that team members could buy a house in Sydney without a mortgage after just a few years. But something extraordinary happened. The entire 15-person team made the same decision. They refused to relocate. Every single one of them chose to stay in Australia and walk away from Microsoft's golden handcuffs. Instead, they formed a new company called Emergence Quantum, a startup focused on the same quantum control technology they had been developing. A leading professor and a key researcher led this rebellion, keeping their core team of 20-some PhDs intact and motivated. The most shocking part, within just 1 year of Microsoft shutting down their lab, Emergence Quantum partnered with another Australian quantum startup called Dirac and achieved a major scientific breakthrough. They published in Nature, showing their cryogenic control chip integrated with Dirac silicon qubits could operate at the same ultra-cold temperature without degrading quantum performance. This solves the final piece of the puzzle. Their chip doesn't just work in theory, it works in practice with real quantum bits, eliminating miles of wiring and shrinking the footprint of quantum computers dramatically. It's like watching a band get dropped by their label and then release the album of the decade. They didn't leave the game, they reinvented it and started generating revenue from day one through partnerships with defense agencies and other quantum companies. Here's where it gets even wilder. Some believe this wasn't just Microsoft losing a team. It may have been a strategic move all along in the high-stakes quantum chess game, where the prize is unraveling the universe's quantum code. From black hole event horizons to potential simulation glitches in reality itself. Trojan horse or burned bridge? Here's where things get truly fascinating. Some industry insiders are quietly asking, was the formation of Emergence Quantum quietly approved or even encouraged by Microsoft? Could this be a strategic play to develop quantum control technology in the open? While Microsoft focuses on its proprietary qubit architecture, this theory isn't as far-fetched as it sounds. Microsoft still holds the core patents on the technology developed during those 7 years. The intellectual property rights for the cryogenic control chips created before 2024 remain firmly in Microsoft's hands. What happens when Emergence Quantum builds something that's inevitably similar to their previous work. We could be looking at a Waymo versus Uber-style legal showdown where Waymo sued Uber for billions after claiming their self-driving technology was stolen by former employees. The most intriguing part, both Emergence Quantum and Microsoft are now working with defense initiatives on quantum projects. Emergence was quickly integrated into quantum benchmarking efforts, while Microsoft's topological qubit project advanced in utility-scale quantum systems programs. Is this just coincidence, or are we witnessing a backdoor reunion happening through government partnerships? Could Microsoft be using Emergence as an external research arm, gaining access to innovations without the overhead of maintaining the Sydney lab? The leading professor described Emergence as qubit agnostic, focusing on the connective tissue that works with any quantum processor. This positioning conveniently avoids direct competition with Microsoft, while potentially creating technologies Microsoft could license back. What shut down in Sydney may actually become the backbone of quantum control systems worldwide, and Microsoft might still be pulling the strings from behind the scenes in ways we don't fully understand yet, especially as these systems promise to simulate cosmic phenomena like quantum foam at the Planck scale or detect gravitational waves from merging black holes with unprecedented precision. What this means for the quantum arms race. While this corporate drama plays out, the stakes in the global quantum computing race couldn't be higher. Microsoft's Majorana 1 chip represents their bet on topological qubits, an approach fundamentally different from what IBM, Google, and others are pursuing. If it works, these topological qubits would be intrinsically protected from errors and vastly more stable than conventional qubits. Microsoft boldly claims this approach offers a path to developing quantum systems that can scale to 1,000,000 qubits in a device the size of your hand. This isn't happening in isolation. The US government is pouring billions into post-quantum infrastructure through the National Quantum Initiative. There's mounting concern about quantum computers eventually breaking current encryption standards, potentially exposing everything from banking systems to national security communications. The quantum AI implications are even more staggering. These aren't just computers for running chemistry simulations. Topological quantum computers could theoretically train massive language models, orders of magnitude faster than today's best GPUs. Some researchers believe the first practical application could be quantum-enhanced AI for breaking complex codes or powering advanced defense systems, explaining the Pentagon's intense interest in accelerating development. But beyond that, imagine using these machines to model the quantum behavior inside black holes, where gravity warps space-time and information paradoxes challenge our understanding of reality. Or to simulate entire universes, testing simulation theory by probing whether our cosmos is a vast quantum computation, with glitches revealing the code beneath. Quantum computers like these could analyze vast datasets from telescopes like the James Webb, sifting through exoplanet atmospheres for biosignatures of alien life, or decoding anomalous signals from deep space that hint at intelligent civilizations. Recent discoveries, like the 2025 detection of potential technosignatures in the TRAPPIST-1 system, could be verified or debunked overnight with scalable quantum power. If Microsoft succeeds with their topological approach while controlling the cryogenic interface technology, either through their patents or future deals with Emergence, they could leapfrog every competitor in the quantum race overnight. Billions invested in superconducting quantum hardware by IBM and Google could become obsolete almost immediately, like investing in vacuum tubes just before transistors were invented. If Microsoft gets this right, we're not just talking about faster computers. We're talking about rewriting the infrastructure of intelligence itself, from how we encrypt data to how we train AI, and extending to cosmic scales, unlocking the secrets of time dilation near black holes, exploring quantum entanglement as a bridge to parallel realities, or even confirming if our universe is one of many in a multiverse foam. The company that controls this technology controls the future of computing, and by extension, our grasp on the cosmos's most profound enigmas. Australia's missed weapon. While Microsoft centralizes in the US, Australia faces a sobering reality. They just lost what may have been their most advanced quantum R&D team. The Australian government was reportedly caught completely off guard by Microsoft's decision, learning about it from press reports rather than direct communication. This came at an embarrassing moment for Australian officials, who had just invested hundreds of millions into building a domestic quantum industry. The timing couldn't have been worse. Australia had just released its first national quantum strategy, aiming to position the country as a global leader. The irony is staggering. Australia's government spent nearly 1 billion Australian dollars to lure an American company with Australian roots to set up operations in Brisbane. Meanwhile, Emergence Quantum was homegrown talent that emerged from their own universities and could have been supported directly. Now, Emergence Quantum operates as a free agent in the quantum ecosystem, open to partnerships with American defense agencies, European research initiatives, or potentially even international collaborations that could veer into uncharted territories. Nothing prevents them from taking their expertise wherever it's valued most. In essence, Australia may have just exported the control layer of post-classical computing, a critical technology that could determine who leads the next generation of computing infrastructure. The very interfaces that will make quantum computers practical might now be developed for the highest bidder. If your country just lost its best quantum minds to foreign governments and multinational corporations, do you feel safer or completely sidelined in the most important technological race of our lifetime, especially when this tech could be the key to simulating cosmic inflation, probing the quantum origins of the Big Bang, or detecting subtle anomalies in cosmic microwave background radiation that suggest hidden alien influences or simulation artifacts? And here's the final twist. Microsoft didn't leave quantum computing, they just went dark. Microsoft's silence strategy and speculation. Since shutting down the Sydney lab, Microsoft has grown increasingly secretive about its quantum operations. Media access has been limited. Public lab tours have ceased, and technical details are shared only through carefully controlled channels. Their February 2025 announcement of the Majorana 1 quantum chip was met with skepticism from the scientific community. Microsoft claimed to have created the world's first quantum processor, powered by a topological core with 8 functional qubits. But physicists at the American Physical Society meeting described the data as incredibly unconvincing, like a Rorschach test. Some attendees called the evidence too noisy and interpretive to conclusively prove a working qubit. Yet Microsoft continues to push forward behind closed doors, apparently confident in their approach despite the criticism. A corrected study in 2025 rekindled the debate, highlighting controversial claims about elusive Majorana particles that could underpin robust quantum chips. Microsoft insiders have quietly promised a full-stack prototype quantum computer by 2027, one that could theoretically scale to millions of qubits in a relatively compact device. Their silence on technical details has only fueled speculation about what's really happening inside their labs. Is this the classic tortoise strategy? Let IBM and Google flash their 100-plus qubit demos with inherently limited architectures, while Microsoft methodically builds a completely different machine that could render them all obsolete. They're not rushing to show off, and maybe that's the point. Because if you were sitting on a nuclear breakthrough in computing, you'd stay quiet too. The less your competitors know about your true capabilities, the greater your advantage when you finally unveil the finished product, especially if that product could simulate the quantum turbulence around black holes, revealing whether information is truly lost in their depths, or model quantum gravity theories that unify relativity and quantum mechanics, potentially opening doors to time travel concepts or wormhole navigation. Recent astronomical data from 2025, like the Event Horizon, telescopes' enhanced images of Sagittarius, a star, could be analyzed quantumly to uncover hidden truths about space-time curvature and possible gateways to other realms. Yes, Microsoft shut down their Sydney Quantum Lab in a move that shocked the research community. But what Microsoft walked away with wasn't just research papers. It was control over patents that could determine the future pipeline of quantum technology development. The intellectual property rights to 7 years of groundbreaking work remain in Microsoft's possession. Even as they consolidate operations in the US, they retain legal ownership of innovations that could prove essential for any company trying to build practical quantum computers. Emergence Quantum's meteoric rise proves the knowledge isn't lost, but it now exists outside Microsoft's walls. The team's decision to remain united and independent has created a new power player in the quantum ecosystem, one that's already partnering with competitors like IonQ to advance quantum systems in Australia and beyond. Their July 2025 collaboration aims to harness combined expertise in systems engineering and quantum control, potentially accelerating breakthroughs in cosmic simulations. What happens next? Collaboration or conflict could shape the future of computing as we know it. Will Microsoft license technology back from the very team they let go? Will patent disputes emerge as Emergence develops new systems based on their expertise? Or will the quantum industry fragment into competing ecosystems that don't interoperate? The answers to these questions will determine whether quantum computing becomes a practical reality in the next 5 years, or remains trapped in research labs for decades. The Sydney lab is gone, but the technology it pioneered is alive and evolving, perhaps faster now that it's freed from corporate constraints. And the stakes in this quantum race are higher than anyone in the mainstream tech press is reporting. We're not just talking about faster computers or better simulations. We're witnessing the birth of entirely new computing paradigms that could upend global power structures, redefine artificial intelligence, and transform how we secure our most sensitive information. But more profoundly, these advancements could pierce the veil of cosmic mysteries, confirming if black holes harbor firewalls of quantum information, if simulation theory explains the fine-tuning of physical constants for life, or if quantum networks could one day detect entangled signals from alien quantum computers across the stars. The quantum race isn't slowing down, and as it accelerates, it drags us closer to confronting the awe-inspiring, fear-inducing truths about our place in an infinite, possibly simulated universe.